So in the probability and stochastic process, what is the important here? First, because if you take all real-time signals, okay, all real-time signals are random in nature, okay. So what is random? You cannot predict the value of the signal. For example, electron emission, okay, we cannot predict the electron emission. And telephone calls, can you predict when you get telephone call? We cannot predict, okay. Say radar detection, quality control, system failure, games of chance means what? When we are playing, throwing die, okay, or tossing the coin, all these are the games of chance, okay. Birth and death rate, okay, random walks, and probability of detection, probability of false alarm, and BER calculation, optimal coding, and many more. All these are random in nature. You cannot predict all this. Okay. So that is why what we do here, we have to represent this mathematical form for random signals. Okay. So how do we represent mathematical form for random signals? That can be done by using the stochastic process or random process. Using this only we can obtain mathematical form. What is the importance of obtaining mathematical form? So if you obtain mathematical form, we can able to analyze the signal. Okay. So to analyze the signal, we have to have mathematical form for all the random signals. Okay. So you might have studied in signals and systems that, okay, we have two types of signals, that is deterministic signals and random signals. What are the deterministic signals? Deterministic signals is that you can predict the value of the signals. Those signals are called deterministic signals. Okay. What are the random signals? The random signals is that you cannot predict the value of the signal in advance. Okay. So those are the called random signals. Okay. So and we know that for deterministic signal we will be having mathematical form. Okay, you have a mathematical equation for deterministic signal. So if you substitute any time value t value, you can find out what is the value of the signal at that particular time t. Okay. So whereas for random signals, we cannot predict the signal value. Okay. So what is the importance of this subject here? The importance of this subject is we have to analyze random signals. Okay. To analyze the random signals, we should have mathematical form. Okay. So here we will be obtaining mathematical form of those signals. Okay, and so that we can analyze the random signals. That is the importance of this subject. Okay, so first we will be studying what is probability. Okay, so what is probability? Probability is measure of likeliness that an event will occur. Okay, so we just measuring how oftenly that particular event is occurring. Okay, for example, if you are tossing a coin, when you toss a coin, we'll be getting head or tail. Okay, so what we do here, in probability we will be tossing this coin for 100 times. Okay, and we will be measuring how many times we are getting head, how many times we are getting tail. Okay, so that measure of occurring particular event is called probability. What is the event here? Getting a tail or getting a head is the event. Okay, so that is called probability. Okay, so to study this random signals, we will be this will lead to what is that? Random variables and random process. Okay, so the using this only random variables and random process, we can able to obtain mathematical form for the signals. Okay, so now, mostly what is that? For example, when you tune to radio, okay. So when you tune to radio, what happens? We will be getting some sound, background sound we will be getting. That sound is called hiss. We are getting a background hiss, okay. So when you measure this hiss on oscilloscope, what happens here? We can see that this sound is randomly fluctuating voltage with the time, okay. So it is not constant, it is randomly fluctuating with time. Okay, and what is this called? Noise. So noise is the example for random. okay, random signal. Okay, so in television system also this appears in the form of snow. Okay, nowadays you cannot have this because we have high digital systems. Okay, so where will not be getting noise, but in radio you can see that you will be getting some background hiss, no sound. Okay, that is called what? Noise. Okay, in television also when we have a snow, that is called noise. Okay, we will not be getting signal clearly, we will be getting some dots. Okay, so that is called noise. Okay, in sonar, randomly generated sea sounds. Okay, so in sonar what happens, we will be getting background sea sounds. Okay, so this sea sounds will give us noise. These are the examples of noise. So these are nothing but random signals. You cannot have the equation for that, yes or no, because it is randomly fluctuating, so that we don't have any equation for that. Okay, and similarly all these noise signals does not have mathematical equations. Okay, and these are called random signals. Okay, and the output voltage of wind power generator is random due to random fluctuation of wind. Okay, when you measure the output voltage of wind power generator, okay, so wind power generator output will not be always constant, no, it depends on wind. See, and we also not know that wind is random signal. Okay, so that we get a voltage is also random in nature. Okay, and similarly the solar detector, if you are using solar detector, if you measure what is the voltage we are getting from solar detector, it is also random in nature. Okay, and similarly the information of antenna transmission, all such phenomena must be described by some probabilistic manner. All these are random, so how you describe this? We will be describing by using probabilistic way. Okay, so all random signals are described by probabilistic way. So what is the importance of this subject? We are attempt to develop a mathematical tools for analysis and quantitative characteristics of random signals. Okay, to be able to analyze the random signals, we need to understand what is that random variables. The resulting mathematical topics are called probability theory, random variables, and random process. So in this course, we shall develop the probabilistic characteristics of random variables. Okay. So what is the importance of this? We should able to obtain mathematical tool. Okay, that's what I told. We have to obtain mathematical equation to analyze the signal, so that you have to obtain the characteristics of the random signal. So once you know characteristics, so from the solar detector how much voltage we will be getting in which time. Okay, everything characteristics means how it is acting according to the time. So everything we will be able to analyze. Okay, so to do that, what we have to do, we should understand random variables first. So once we understand random variables, so that we can obtain the mathematical equation. How do you get mathematical equation? By using probability theory, okay, random variables and random process. So using these three, see here, first we have to understand probability theory, random variables and random process. Once you understand this, we can able to obtain the random nature of that is called probabilistic characteristics of random variables. Okay, so whatever signal we are getting is random signal, no ma. So what is that? We will be able to get the randomness of that particular random variable. Okay, for example, if in the solar detector, the voltage you are getting from the solar detector is called random variable. Okay, so what is that? Noise. Which is the noise here? The voltage from solar detector is the noise. Okay, that is called random variable. Here also, what is the output? Output is output voltage from the wind power generator. So what is our importance here? Our importance is to measure this random variable. Okay, we have to obtain mathematical model for this random variable. Okay, so what is the random variable here is output voltage. Okay, so that can be done by how it can be done. It can be done by understanding probability theory, random variables, and random process. Okay, so now we discuss what are the basic concepts of set theory. So to understand probability theory, what is that? Introduction is set theory. Okay, so first in set theory, what is set here? Set is nothing but the well defined collection of objects. Okay, so a collection of objects is called set. For example, okay, if you take what are the say for example, what are the aeroplanes we have? We can have all aeroplanes, a jet, okay, like that, different aeroplanes. Or what are the different types of cars we have? So we can write all shift, okay, like that. We have whatever different cars we have, all that we can denote in this set. Okay, so all well defined collection of objects. It is belong to one particular class. Here we are discussing about cars. Okay, all the cars will be represented here. Okay, here we are discussing about aeroplane. All the aeroplanes will be denoted in this particular set. Okay, so it is called well defined collection of objects. Okay, and all this individual object you have no more. The individual objects are called the elements or members of the set. Okay, and how do we denote? We denote capital letter. We use capital letter to represent the set. Okay. And the elements of set we will be denoted by the lower letters. Okay. So the lowercase letters we use to represent the elements, and capital letters we use to represent the set. Okay. Now, for example, here we are taking the set of even numbers. Okay. So, for example, you take set of even numbers, or like this, or set of ovals. Okay, what are the ovals? A, E, I, O, U, no? So like this, these are the set of ovals. Okay, so this particular set is having the set of ovals. What are the set of ovals is A, E, I, O, U. Now, for example, just now we have discussed, now how do you represent set? Set will be represented by a capital letters, and the elements of set will be represented by the lowercase letters. Now you see here, A is element of capital A. Okay, how do you denote this? A belongs to capital A. Like this we will be denoting. Okay. Now, for example, B. You don't have B, no? Do you have B here? We don't have B. So B is not belongs to A. How do you denote this? B is not present in A. So that is why we will be denoting it like this. Okay. So when any particular element is in set, we denote it as A belongs to capital A. Okay, if any other element which is not present in set, then we write it as B is not belongs to A. Okay, B is not belongs to A is belongs to A. Like this, we will be denoting the set. Okay, elements of the set. So what is that we have discussed? Set is nothing but the collection of objects, and each object in the set is called elements or members of the set. The capital letters we use to represent the set, and lowercase letters we use to represent the elements. Okay. Now we'll discuss what is empty set and null set. Okay. So what is empty set? Empty set does not contain any element. Okay. It should not contain 0 also. It does not contain any element. Then that is called empty set. Okay. And it is also called null set or void set. Okay, and how do you denote? You denote it by pi. Okay, and so pi is the empty set, and we know that if it does not have any element also, this is also called finite set. Okay, so the number of elements in the uh, okay, so here you see the example. So what is empty set here? The whole number less than 0. You don't have any whole number less than 0, no? No whole number. We don't have any whole number less than 0. So set will be empty. You don't have anything. And similarly, you see here n value. N is equal to x, where x belongs to capital N, where 3 less than x less than 4. Between 3 and 4, do you have any number? Means whole number. Between 3 and 4, we don't have any whole number. So what is n here? N will be empty set. Okay, it does not contain element. Okay, so if it is have 0 here, then it is not empty set ma. Empty set means what? You should not contain any elements. Okay, then that is called empty set. Okay, and it is also called finite set. And here also you see here, a is belongs to a is equal to x, where x value is between 2 and 3. where x value is between 2 and 3. What is x? X is a natural number. Okay. Between 2 and 3, we don't have any natural number. Okay. That is why what is A here? A is a empty set. Okay. So between 2 and 3, there is no natural number. So A is empty set. Okay. How do we represent sets? Sets will be represented by two methods. One is called tabular method of representation. The other one is called rule specified method of representation. These are the two methods we use to represent the sets. Okay. So what is tabular column method of representation? We will be using each and every element here. For example, like this 1, 2, 3, 4. Okay. What is rule based? Rule based is like this. Here we have used, no. This is called rule based. Here we are using some rule. Okay. So that is A is equal to X, where 2 less than X less than 3, where X is a natural number. Okay. So this is called rule based method of representation. Whereas if you represent all the numbers like this is called tabular method of representing the sets. So there are two ways to represent the sets. So what is a finite set? Finite set contain finite number of elements, means the elements can be countable. So that is called finite set. Okay. So for example, set of all colors in the rainbow. We can count no number of number of colors in the rainbow. Okay. So we can count till 2000, 3000 also we can able to count. Okay. So you can have all the elements like that. Okay. And here see here n. So like this, if your set is represented like this, the set of all colors in the rainbow. Okay. So it is a statement, no? So this way of representation is called rule-based method of representing the set. Okay. And here see n value. N value is equal to x, where x belongs to n, means x values are belongs to n. Okay. What is x values? My x values is are less than 7. So what are the values of values of n now? It is having the values less than 7. Okay. So it is 1, 2, 3, 4, 5, 6 till 6. Okay. Or 0, 1, 2, 3, 4, 5, 6. Okay. Like that. We'll be having the elements from 0 to 6. Okay. So is it countable? It is countable. It is able to countable means then it is called what? Finite set. Now see here p values. P is having the values 2, 3, 5, 7 like this so on till 97. What are these numbers? Can you tell me? These are the prime numbers. The prime numbers less than 100. Okay. All these are the prime numbers. We can able to count, no? We can able to count these numbers. Okay. So that is why this is called finite set. Okay. So a set which contains definite number of elements is called finite set. An empty set. What is empty set? Empty set does not contain any element. Okay. So it is also called finite set. What is empty set? It does not contain any element. Okay. So no elements here. We can able to count it. Okay. That is why empty set is also called finite set. Okay. What is infinite set? A set whose elements cannot be listed or cannot be counted. Okay. The set containing never ending elements is called infinite set. Okay. So for example, the set of all points in a plane. If you take this plane, this is the plane. If you count number of elements here, we cannot count. The elements will be infinite number of elements. Okay. So then it is called infinite set. Okay. So if it is having never ending elements, then it is called infinite set. And if the elements cannot be listed, means you cannot able to list it, count it, then it is called infinite set. Now we see that cardinal number of a set. So the number of distinct elements in a given set A is called cardinal number of cardinal number of A. Okay. So how do you denote? You denote it as n of A. Okay. So for example, you have this set no A. A is equal to 1, 2, 3, 4. So number of distinct elements. Number of distinct elements are 4 here. Okay. For example, you take this set ma. ALGE, okay, algebra, 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 no? In this, what are the number of distinct elements? A is repeated 2 times, no? A, Letter A is repeated 2 times. So you should not write 2 times. You should write only once. Set will have all distinct elements. Okay. It does not have any repeated elements. Students, you see here, set does not have any repeated elements. Okay. So here in algebra, A is repeated 2 times. So we have to consider only 1 time. Okay. And all others, L is only 1 time, G is 1 time, E is 1 time, B is 1 time, R is 1 time. Okay, all others are 1 time. So number of distinct elements. A is repeated 2 times. You should not consider 2 times. We have to consider only 1 time. Now, if you count number of elements here, what is that? Number of elements will be equal to 6. Okay. So, for example, here you have the elements like this. We have the elements like this. Okay. Students, see here, the elements are like this. Okay. How do you represent this as a set? How do you represent this as a set, ma? Now we have to write it as a set. How do you write it as set?
1, 2, 3, 4. Covered
Yeah,
bracket.
1, 2, 3, 4. Okay. So because 2 is 2 times, 3 is 2 times, you should not write. When you are writing set, you have to write only 1 time. You should not repeat the elements. Now you count how many number of distinct elements are there. You have only 4 elements. Even though here we have 6 elements, but the number of elements, cardinal number of a set will be equal to 4 only. Okay. Now, what is that equivalent set? The two sets A and B are said to be equivalent if their cardinal number, that is n of A, is equal to n of B. Okay, so the symbol is denoting, how do you denote this? We will be denoting by this symbol. Okay, so this is called what is that? Equivalent set. Okay, so for example, here A is having 1, 2, 3. For example, B is having ABC. A is having 1, 2, 3. B is having ABC. What is cardinal number of A is 3. Cardinal number of B is also 3. So this is called equivalent set. You no need to have the same elements. Okay. The same elements you no need to have. But what is that we should have? The cardinal number of A should be equal to cardinal number of B. That's all. Then what is that called? These sets are called equivalent sets. Okay. Now we'll discuss what is equal sets. Okay. Two sets A and B are said to be equal if they contain the same elements. Okay. And every element of A is also the element of B. And every element of B is also the element of A. Then what is that called? We call it as equal sets. Okay. So you no need to have the same order. See here A is having P, Q, or S, whereas B is having P, S, or Q. Okay. So every element of A is also present in B. Every element of B is also present in A. Okay. So what is that? A is equal to B. Then it is called equal sets. Okay. So you understood what is the difference between equivalent set? Equivalent set means what? It should have, it is no need to be having the same elements. We no need to have the same elements here in the equivalent set, but cardinal number of A should be equal to cardinal number of B. Then we call it as equivalent set. Okay. So that is number of elements in A should be equal to number of elements in B. Whereas what is equal set? All elements in A should present in B. All elements B should also present in A. Okay. Then what is this called? Equal set. Okay. Now we call it we'll discuss what is disjoint set. The two sets A and B are said to be disjoint if they do not have any element in common. You should not have any element in common. Then we call it as disjoint set. For example, if A is equal to 1, 2, 3, okay, B is equal to ABC. See, do you have any element in common here? We don't have any common element. So then what is this sets A and B are called? So these sets are called disjoint sets. Okay. So you should not have any element in common. Then these sets are called disjoint sets. Okay. Now we'll discuss what is subset. Subset is nothing but if A and B are two sets, every element of set A is also element of B, then A is called subset of B. Okay, how do you write subset here? You see here, A is subset of B. This is the symbol we use to represent the subset here. So since here there is a equal sign here, see here, since there is a equal sign here, means that every element, whatever elements are present in A is also present in B. Okay, if there is no element equal sign, see here, if there is no equal sign, it means that B is containing at least one element greater than A. Okay, so means that like this. Okay, if A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5. Okay, so what is B here? B will be equal to 1, 2, 3, 4, 5. So what happens here? All elements of A is present in B, and B is containing at least one element is greater than A. So here it is containing two elements greater than A. So what is this called? A is called proper set of B. A is called proper set of B. Okay. In this case, you see here, A is not equal to B. A value is not equal to B. Yes or no? A is not equal to B for proper set. Whereas for subset here, when you use equal sign here, then A value is equal to B. Number of elements in A will be same elements will be present in B. So then these two are called equal sets. Okay. What is superset? Okay. So if A is subset of B, then what is B called? B is called superset of A. Okay, so A is subset of B, then what is B called? B called superset of A. How do you represent this superset? We'll be representing this superset by this is the symbol. Okay, universal set. Okay, a set which contains all elements other than other given set is called universal set. Okay, how do you represent universal set? We represent it as U. Okay, now for example, if A is given as 1, 2, 3, B is given as 2, 3, 4, C is given as 3, 5, 7. What is the universal set? It will contain all the elements of ABC. Now if you see this here, 2 and 3. Okay, 2, 3 is repeated, no? 2, 3 is repeated. When you are writing the set, you should not repeat it. Yes or no? So you see here, it is like this. Now A is subset of U, B is also subset of U, C is also subset of U. Okay. And what is U now? U is superset of A. Okay, U is also superset of B. U is also superset of C. Okay. Now we'll see some examples here. A is given as 1, 2, 3, 4. Okay, 4, 1, 1, 3, 5, 7. So what type of set it is? Finite set. Can you can able to count it? Yes or no? So it is called finite set, and it is countable, and it is in which form? It is in tabular form. Okay, it is not given any condition here. So what is this called? Tabular form of representation. Whereas here is it is infinite set because the dots are given, you cannot count it. Okay, it is